Hello all, and thank you for listening to another video of Mr. Laxton talking through these Algebra II Section 6.2a notes. Alright, so we broke Section 6.2 into two sections, 6.2a and 6.2b. I will post the video for 6.2b as well. But the 6.2a, we're really just focusing on this evaluating a polynomial at a function. Okay, so we're talking about polynomials, what they are, what they look like. But this first section we're looking at, my essential question, how do I evaluate polynomials at a given value? Okay, we're going to learn kind of the most common way, and then we're going to kind of learn a trick way to make it a little bit quicker for us in the end. All right, so here we go. A polynomial function is the form, this f of x, all this guy here. And I don't want you to get too confused on this. Don't beat yourself up about this. I know there's a lot of different variables and a lot of different things going on there. But this is really saying, hey, this n, that first n is your degree. That's the highest exponent. So highest exponent. So that might be like x to the fourth power exponent. Highest exponent there. That is your highest exponent. And then this a to the n right here is your leading coefficient. All right. Kind of the main things that we're going to look for, and this a to the 0, that's got your that's your constant term that has no x's, so no x's attached to it. All right, and again here the exponents are all non-negative integers. Okay, so this means that these are positive whole numbers. All right, so you can't have any fractions for exponents. You can't have any negative exponents. Kind of a couple things there. Okay, so polynomial in standard form, this is going to be huge. We're going to write this a lot, is written with their descending order of exponents. Okay, so that means that your highest exponent comes first and your lowest comes last. So notice here that if I have this 3x squared minus x cubed plus 8 minus 2x, notice that here in standard form that term with the x cubed comes first, then I go x squared, then I go x, and then I go my constant, that 8. All right, so that is kind of the way that we like to write it in standard form. You're going to see a lot of these answers, at least in standard form. All right, so here we go, the types of polynomial. Degree of 0, so that's this first one here, that is a constant. So that's like if I have like the equation y equals 4. All right, that is a standard form polynomial, but it's just a constant polynomial. All right, that's what we like to call it. All right. The next one is if I have a degree of 1. So that's my highest exponent again. So highest exponent. So if my highest exponent is 1, it is linear. All right, that's like y equals mx plus b. That is linear because it has x to the first power. All right, it doesn't have any x squareds or x cubed or anything like that. It just has x to the first power. The second one, quadratic. We've looked at a lot of those in factoring so far. Those have x squareds, okay, and they might have an x and they might have a constant, but it has the highest exponent of x squared. All right, my next one, if I have a cubed, my highest exponent is a 3. All right, and then I go 2, then I go 1, and so on. All right, and the 4 is what we call quartic. This has an x to the fourth polynomial. We'll look at a few of those in the last parts of chapter 6 here. All right. So here we go. Do you have a polynomial function? If it is, write it in standard form and then state the degree, type, and leading coefficient. All right, so this first one, is it a polynomial function? No, it is not. Why is it not? 1/2 cannot be an exponent, so it has to be a positive. 1/2 is not a positive whole number. All right, so now if I just kind of look down here, what's another one that doesn't work? If I look at number 4, number 4 has a -2 there, so no, -2 is not a positive whole number. All right, so now let's look at number 2 and number 3. Are they or are not they? I did not want to do that. I wanted to go draw. There we go. Pick up my red. If I have f of x equals 3, sure. Yeah, that is, absolutely. It's got no negative exponents and no fractions. Yes, so now I have to state the degree. So degree is equal to 0. The highest exponent you see is, there's none, there's no x's. So this would be like the same as plus x to the 0 power. And remember that x to the 0 power, it's just not there. Or there's no, it's not plus, this would be times, excuse me, times x to the 0 power. So that'd be 3 times 1. All right. So my degree there is 0. I have to state my type. The type over here, if my degree is 0, my type is a constant. All right. And my leading coefficient, I'm just going to abbreviate that with my LC. My leading coefficient is the only number that you see there. It is 3. All right. Number 3, we have f of x equals the square root of 5 minus x. Notice here that the highest exponent that you see on an x is 1. It's not there, but if it's not there, it is 1. So my degree, this is yes. My degree is 1, which is type of linear. All right, remember if I have degree of 1, it's linear. And now my leading coefficient is the first number that you see in standard form. So in standard form, this is going to be negative x plus the square root of 5. So my leading coefficient is negative 1. All right, so make sure you write those guys in standard form. The main thing is there that the exponent has to be a positive whole number. All right, if it has an exponent that's not a positive whole number, it's not a polynomial. All right, so here we go. The first one we're looking at, we're going back to my essential question, and it says, how do I evaluate polynomials at a given value? So this first type that we're going to look at is just direct substitution. So when it says, hey, evaluate when x equals 1 this polynomial, all we're going to do is we're literally going to plug negative 1 in for all of my x's. So we're going to plug it into that x, and we're going to plug it into that x, and we're just going to simplify it and go from there. Okay, so that's nothing too crazy here, but you got to be careful with these exponents. So f of negative 1, remember that notation that we like to write, is equal to 14 minus 21. And instead of writing x, I'm going to write negative 1 squared plus 5 times negative 1 to the 4th. Okay, so now let's just go through and figure this guy out. I have 14, that doesn't change. Negative 1 to the 2nd power is going to be positive 1. So 21 times 1 plus 5 times negative 1 to the 4th power is going to be negative 1 times negative 1, which is positive 1, times negative 1, which is negative 1, that's 3, times another negative 1 is positive 1 again. So here, so now this is going to be 14 minus 21 plus 5, and 14 minus 21 is what? Is negative 7, and negative 7 plus 5 is negative 2. All right, so awesome there, negative 2 for that one. Perfect. Great. Now as I go down here to synthetic substitution. Okay, so this is something that's new to you. You haven't seen this before, but we're going to do this a lot throughout this chapter 6. All right, so synthetic substitution, it's a lot easier, it's a lot quicker, I think, to just synthetically substitute this in, and it shoots out our answer for us. Okay, so I'm just going to kind of jump into an example here. You have these 7 steps here for you. If you need them, that's great. But here's what we got. So when evaluating this, when x equals negative 2, I could, in direct substitution, I could go through and just plug that negative 2 in for all these x's and see what you got. Okay, but sometimes when you're doing a bunch of these, that might get a little tedious, and this way for synthetic substitution is actually quicker, and it's actually nicer. And it might be a little tricky at first, but I promise you, after you do some examples, you're going to say, hey, this goes pretty quick. All right, so here we go. This first one here, we're going to evaluate this guy at negative 2. I'm going to put negative 2 outside of this big long L. All right, kind of this big long L shape that we're gonna talk about a lot throughout this chapter. Okay, and then now in here, you write the coefficients of f of x. kind of in here. So my first coefficient that I see, my leading coefficient is 3. And I'm not even going to write my x's, I'm just going to write my coefficients. So that's my x to the 5th. Okay, so now if I look at this one, -1 is my x to the 4th. But then now here's where you need to be really careful. What is your coefficient for your x cubed? Notice there is no x cubed, so you may need zeros for placeholders. So I need a 0 for my x cubed, and I also need a 0 for my x squared. I don't have any x squareds. Now I make it to my x to the 1st, and that coefficient is -5. All right, and my constant comes in at the very end is 10. Okay, awesome. So now here's where here's where the part comes in where we actually have to go through and do this, is that you always bring down the leading coefficient. So 3 comes down here. We always multiply the diagonal. So -2 times 3 is -6. And then you always add straight down. So add straight down, multiply the diagonal. Add straight down, multiply the diagonal. So here we go, -1 plus -6 is -7. Multiply here again, so -2 times -7 is 14. Add straight down is 14. 0 plus 14 is 14. -2 times 14 is -28. Add these guys straight down, I get -28. Multiply the diagonal, so -2 times -28 is 56. Add straight down, you get 51. And then multiply the diagonal, you get -102. And then add straight down again, and you get -92. And this number right here is going to be your answer. So f of -2 is -92. Okay. So like I said, you could have just went through and plugged in this -2 in for all my x's. All right, you could have plugged it in there and just went through and solved it like we did on the last example. But this synthetic substitution, I promise you, is going to be a lot easier once you get this down and keep on going through these guys. All right. So here we go. This last example. Let's go through this guy really quick. I have to evaluate when x equals 3. So the 3 goes out in front of that big long L. And then now I start with my leading coefficient, which is 4. And then I have that's my x to the 4th. So sometimes I like to write this. My x cubed is 2. My x squared, notice there is no x squared. So it's 0x squared if it's not there. So I got to have that placeholder of the 0. Then my x is going to be -1. And my constant is 7. All right, awesome. So here we go. As I go through, and I always bring this 4 straight down. All right, so the 4 comes straight down. Multiply the diagonal. And add straight down. All right, multiply the diagonal, add straight down. So multiply here, that makes 12. Add straight down to give me 14. Multiply here to give me what? 42. Add straight down to give me 42. Multiply here, this gets to some bigger numbers, and that's okay. 3 times 42 is 126. Add straight down, that's a 6. That gives me 125. Excuse me, Mr. Laxton, 125. You cannot write today at 125. Multiply there again, that is 375. Add straight down for my final answer, which is going to be, if this guy goes away, 382. Okay, so that last number is going to be my answer. So f of 3 equals 382. All right, awesome. So go through, plug those guys in. That synthetic substitution, it's a lot easier once you go through and do a bunch of these, and then it's really a lot quicker too than plugging those into just those x's. All right, so again, thank you for listening to that video. We are going to get into 6.2b in the next section. Thanks for listening. Have a good rest of your morning, night, or afternoon.